Hey everyone, welcome back to the channel. In last video, we covered array and linked list, and if you haven't watched those videos, then I encourage you to watch those videos because in this video today, we are going to learn about stack and queue, a very simple and very important data structure. And in this video, we'll use the concept of array and linked list, how we have implemented those in the previous videos. We are going to implement those here because it's fully stack and queue fully depends on array and array list. We'll also talk about what is array list, and we already have talked about linked list. So we are going to implement stack and queue in array and linked list. So you need to have the knowledge of those, and we'll start with this now. See, as why you'll ask me, like, why we need to learn queue and stack. Basically, when you use your websites and all, when you are using any sorts of application, at that there you might have heard of like undo and redo. At that point of time, we use stack there, stack. And for your browsing history, for that case we use queues and all. So these are the some places where we use the concept of stack and queue. And to use the concept, we take to use the concept of stack and queue, we use data structure of linked list and array list. Okay, so they help us to implement the rules of this stack and queue. Okay, so queue is interface. Like I'll tell you what is interface and how to use that one when we'll go to the queue section of in this video. We will begin with the stack section, and I will be explaining you the definition of the stack, and we'll go for the coding part as well. Then I'll give you some questions, interview questions, which we will be solving, and we'll see what are the steps we need to take to solve those questions. We'll see that one as well. Now, before starting this one, before starting into coding part, let's not dive directly into the coding part. We'll see what the concept, the theory concept of stack, why we need stack, and what is stack, and how to use this stack, and when to use this stack. Very important. See, if you know when to use this stack, then that when to use a data structure, that is very much important. For example, like these are some questions you need to have in your mind always, like this, like when to use, when to use, how to use, why to use. These are some questions. What it is, what it is. These are few things you need to make sure you know that one before diving straight into the topic. Okay, cool. Now what we are going to do, we'll answer this. What is stack? Stack. Well, I'll give you a small example of that. I'll show you. Let's say these are some plates. These are the plates where you eat food, right? How we store that? When you go to a marriage place or somewhere, how they store plates? These are some plates. They'll put the plates one on top of each other, right? Like this, they will put it in this format. They'll put it, right? Once they take this out, then only they can access to this plate. After that, they can access this plate. Until unless they won't remove this plate, they won't be able to remove this one. At this format only they can keep, and if they want to get this into this plate, they need to remove all this plate first. Only then they can access this plate. They can take out. They cannot take directly this plate. Are they gonna do that? No, they are not going to take the plate directly from this place. They need to remove all the plates from the up. Only then they can access this plate. So this is what the stack is all about. Now you will ask me why we have something like this. Why we have something like this in data structure? We already have array where we are storing the values in consecutive way, and we have linked list to overcome a problem in the array. Now you are telling me the we are talking about a stack data structure where we were storing in this horizontal way, and until unless we won't remove the top one, we cannot access the bottom one. So what is the use of this? Why we need this one? You'll ask me that. See, for example, let's take an example of undo and redo. Now here, what happens in undo? What is undo and redo? Undo and redo is basically when we are working on some concept, or like while you are working on a website or somewhere you are drawing something or writing something. If you mistakenly have done something wrong, that you want to go back to the previous state where you had saved. Now you haven't saved it, but you want to go to the previous state. So let's say this is your current state. This is your current state, state one, current one. Now let's say this is 1 2 3 4 5 6 7, means sixth number time you have saved something which is really good. Now you want to go back to the sixth state, and now you are in seventh. Now you want to go back to the sixth state. So at that point you need to go only to this. You do not want to go to directly. You will never access to the state one or two. You will go back to the one state. So for that you will do undo. In that case, in undo and redo, while you are implementing this logic in your website, you will use this stack in that. When you will do control S, means when you will save a file in the Word, in Microsoft Word, when you will save a doc, they'll get saved in this format. The first save you will do, that will be in the bottom. Then after that, when you save the second one, it will be in top of that first. Then the third one in the top of the second. Then it goes like that. So when you will do undo, it will go to the previous state. Means now if you are in the seventh, it will do pop up, and you will go back to the sixth one. Now how gonna redo? In the redo also you can again push it back. Understood? So this is what stack is. This is what a stack is. So this is why we need stack. Now, now, now you might have heard of like LIFO, which means last in, first out. In most of your examination, mostly in MCQs examination, they'll talk about LIFO. Some people talk as philo or LIFO, like that. Philo in the sense first in, last out. First in, last out. This is one thing, and both of them are same thing. Okay, FILO and LIFO. LIFO means last in, means the last data, like this plate, the last plate which was inserted is the first one to exit it, to come out. Like last in, this one is the last in, then the first out. That's the way. And the philo means the first in, means this is the first one which goes inside, and the last one to come outside. Like first in, last out. So that both are the same thing. Okay, first in, last out. So these are the characteristics of stack. Okay, so this is something that you need to remember. You need to understand also to remember this lines for the MCQs. You need to, whenever you will give a examination, then mostly they'll ask you that LIFO and philo, what are these things, and how this, they'll give a definition to identify this stack. Okay, now I'll demonstrate this in the code part. Now we'll dive into the code thing as well. Now what we are going to do in the code, see, first thing is, now in this video we are going to implement stack ourselves. We are going to create a stack ourselves, though there is already a stack class present. There is a built-in stack class is present, but we are to understand the stack more depth, we need to implement, we should implement ourselves first using array. We'll use an array to implement stack class, and we'll see how and all things is that. And there is already a built-in stack class which we'll be using whenever will write a code. We just need to create a stack object and we can implement that one. So there are some like methods of stack, like suppose like this is a stack representation is something like this. This is how stack looks, and this is the first place 0th 1 2 3 4 5 and 6, 5 place. Okay, so start from here. The first one which goes inside the stack lives here. So this is the value. Like let's say we have some value called 21, then you have 23, 22, then 23, 24, 25 and 26, and this 25 and 26. Okay, this is how stack lives. Okay, so for that if you want to remove that one, so when we want to put something into the stack, we use a function called, we use a method called push. We'll say like this: stack, the object, this is the object name, stack dot push. We'll say some integer here like 27, then it will go 27 inside. Then we have to remove, let's say we want to remove this, we need to bring out, we will use pop. Here there is no like parameter. Why? Because in stack, when you will delete, you can only delete the first one. We can only delete the top one, which is the top element which is present. We cannot specify any index here. We cannot do that one here. For pushing, we need to give a parameter of parameter is data. Put a data inside. Then if we need to check whether what is the value present in the top. So for that, to check what is the value present in the top, we'll use pick. No parameter inside here because we are not going to identify any index. So then we have like isEmpty. IsEmpty means we are checking whether the stack is empty or not. Okay, so no parameter here, no parameter, only parameter is data here. In the post only. Okay. So now we'll create a class called stack class ourselves. Stack array class, using array we'll create a stack class and we will implement all this function inside this class. So that it will make you understand how this push, pop, pick and isEmpty are using, and how, when to use this all. We'll see that one as well. I have created a folder called stack in the IntelliJ IDEA and a file, a class called ArrayDeque here. Now here we're gonna implement stack using array. Means we'll use an array where we'll save the data. Like this array data structure is being used here to save the data, but you will use a stack. It's a concept like how we are going to store it like on top of each other like that. So in that array only you will save the data in the array. Okay. So for that, for stack, what things we need? First thing, we need an array. Then we need to see if we are using array, then we need to have a specific size of that array. Then the capacity means what the size of that capacity, and a variable which will identify what element is in the top, means in the top, like as we have discussed in the stack, that in the top, like for example, like over here. Now when we will use the pick function, at that point we need to return a value which is present in the top. So we need a variable that will always keep a reading of what is in the top, or whether we'll use that element only in this variable only. Let's say a variable called top. This will it will manage the top element. Like it will always stay with the top element. Also we'll use this to insert a value or to pop a value. Understood? So now we want three things, like one, we'll need array, we'll implement array. Two, the size of that array, like capacity or size. And third, a variable called top. So these are the three things we need. Then we'll have a constructor. Okay, so now let's begin with that. So first thing is we'll write a private. We'll keep everything private, not public. So private int, we'll create an array. Then private int capacity, and we have private, and we have top, right? Int of top. Cool. Now we'll have a constructor of that. So public array stack stack. Inside that, when we'll create as object, we need to specify inside the while creating the object, in that in the parameter we'll put what will be the size of that stack. We need to specify the size of this array here. So in capacity. Okay, so this dot capacity is equal to capacity is equal to capacity. Then we'll array is equal to int new int capacity. Then we'll have top equal to -1. See, at the point, see right now why I have made the top as -1, because see, if top remains here, at this point, if we'll make top 1, let's say we start from 0, if we make top at 0, then what happens, it will point to this element. Now in this part we need to have some value, so that it will initially so that top will point to a value. But in the beginning we won't have any value in the top, right? We won't push any value. If the stack is empty, means there is no value, so there is no use of pointing to 0th place. So that's why we are making the top to point to -1 over here. When we will put something, we'll increment the top and we'll add a value in 0th place. So now the top will point to this value. After that, when we'll push something, again we'll increment the top, and we'll push value in array index top, means array index 1. We'll put a value. So that's how array top is going to help us. Okay, so now the first function we will create here is the push one. Push, like public what sort of value in it in return. In return, when you push something, in return what you will get, you'll get a void, right? There's no need of returning anything, so we void. So pu as a push, but we'll put a parameter called data. We need data to be pushed there. So first we need to check if, means see, there is a capacity, like in array what happens, there's one drawback in array. In array what happens, it's limited to the size it has. If we specify that size of array size is 5, then it will only take 5 spaces, not more than that. 1 2 3 4 1 2 3 4 5, only this much. We can store value in this much. We cannot extend here. So we cannot extend here anymore. We cannot. That will give us a error, null pointer, or not null, like index out of bound. There will be an error like that. So this is one of the drawback. So to remove this drawback, we have array list. Array list is something that is dynamic. If you want to add something beyond 5, then what it will do, it will create a duplicate of this array and it will increase the size. So there is then you can keep on increasing your value. So that's what array list comes to the picture. To make it dynamic, means to make it unlimited, like unlimited in the sense to make it to give us chance to add more values to it apart from the size of array. Okay, so here we need to put the data, and we need to specify whether the capacity, whether stack is full or not. We need to make sure of that. If capacity, if top, means top, that index is greater than or equal to capacity south stack is full and return -1. Cool. Else, sorry, else what? Else put the value in that, put this data in the stack. So for that, what we're gonna do, we'll do array, means we are using array simply here, right? So top is in -1 right now. Top is in -1. So what? So while we'll do push, so top in the beginning, what happens? Top is pointing to this part. Let's say this is the bottom. This is the bottom, and this is the top of the stack. So right now top is pointing to -1. So what we will do? First of thing is we'll increment top. We'll increment top to this index, and now what happens? It becomes 0. Top becomes 0 places. So at now what we'll do? Array top is equal to data. So first we'll increment the top, and then we'll put the data. So there is a way where we'll do like top equal to top plus 1, but the better way is plus plus top. This means first increment the top, then use the value of top. And this is something top plus. That means first use the top value, means first use the -1 value, then increment it. Means it will give it will use in this point. If it is like this, then it will use top value, means it will use -1 value, then it will make it 1. It will make it 0. But if it is plus plus top, then this will first get incremented, means -1 will become 0, then it will use the value 0, then it will increment the value from -1 to top 0, then it will use the value of top. Now it will become 0, now it will use the value 0. So this is how it works, and it tells in 0th array of 0th index, put the value data. Understood? So plus plus top equal to data. Understood? So now this is how it is done. Now next step is we have pop method. So what is pop method? So in pop we'll get a return. In return we'll get a int value, int pop. So there's no parameter for this. So here what happens, here the base case will be, if let's say if the stack here, if the stack is empty here, if the stack is empty, there's no value in the stack, if then top will be in the -1 place, right? So if you do pop, means removing an element, then that's not possible. So at that point of time we need to give a return the value called stack is empty. So if top is equal to -1, return -1. Will simply return -1 at that point of time. Okay. Yeah. Okay. Also south stack is empty. Else if stack is not empty, so what are we going to do? If you want to remove 26 from here, so top will point at this point of time when it's fully. So what we will do, we'll just make the top to point at this point. Okay, we'll make that top to this one. Okay, so what happens when next, so now it will point, top will be our 25, not 26 anymore. When something will push, then it will go up and it will replace this 26, and that value will come in place. Understood? That's it. Cool. Okay, right. So at this point, what we will do, what we will be doing, we will return this value. We will return this value. No matter, we'll return this value, and we'll decrement the top from this place to this. Understood? Okay. So what we're gonna do here is make me array return, simply return array top means what we are doing, return array top means return this top first, then do minus minus means after that decrement the top size. So after uh, giving in the index this value, then decrease the top to this. So now you'll ask me, so what happens to this? That does it remains like this? No, it won't remain like this. So how we are not deleting it, right? So how it's not going to remain? Because when you will do push again, when you will push some value here, what happens? Top will get increment to this place, and at this point array index 5 is equal to some xyz value. So at that point what happens, this will get automatically replaced by that value. So it's like that, we are not deleting this value, you are just replacing with when you will do push. That's what happens. Okay, so this was the pop. Now what we're going to implement, we'll implement the pick value. Pick is very easy. Public kind pick, no parameter for this as well. So in pick value what happens, if stack is empty or not empty, that doesn't matter here or what. So still we'll say something like if top is equal to -1, south return -1, else return top, because peak is means the first top value. So simply the top value you are going to replace, sorry, return here. So then next is whether the value is empty or not, whether the is empty. Public is empty or not. Is empty is a boolean. If so, boolean will be if top is equal to -1, then return true. Means what happens? Means top is pointing to else return false. Okay. Means if the top is pointing to -1 means there is no value, that means so in that point it is true, it's empty. Else if top is not pointing to -1, then it is false. There is some value in the top. So this is what the implementation of stack using array. Now we will create an object of array stack as we have already implemented it. Now array stack is completed. We have created all the methods like post, pop, pick, and isEmpty. Now we will create a object of that. I have created a main class called name. I created a class name main, and I have created this. And here I will create an object of array stack. Okay, which we have just created. So array stack new array sec. Inside that we need to specify a capacity. Let's say capacity of 6. So stack dot push, inside that we need to put some value. So 21, then stack dot push 22, stack dot push 23. Okay, now let's say stack dot pick. We need to, as they are going to return in int is returning, so we need to print it, right? So system dot out. Then we need to print stack dot pop, then system dot out dot println stack dot isEmpty. Okay, yeah, see, now it's working. So okay, so let's run it. See, okay, stack dot pick, it's returning us 2. Yeah, see, we are returning the value of this top. Here in the pick there is one small error. We should not return the value of pick. We need to return the index value. Like this is the index value. We need to return array of index this top, means the array index of 2. We need to return that value inside. So what we're going to do, array top here, and rerun it. Okay, now it's working. So in the peak, means in the top it will be 23. So last push was 23. So in the top it will be 23. Then we pop 23. Then let's check what will be the next. And after pop the peak will be 22. Yeah, we the peak was 23. Then we popped it. Then pop value was 23. Then we checked again the top value, which was 22. Then we checked whether it is empty or not. So so everything is perfectly working. Now we'll see the built-in. Now we have created this ArrayDeque of our own to understand the method and everything. But while we are working on stack while solving a problem, while using the stack method and a stack thing concept, we are not supposed to make this class ourselves. We will need to use a built-in stack class. We no need to create your own stack class. There is already present, like stack of stack is equal to new. This is, we are getting the object of stack class. See, this is already Java util. They already provide us a stack class. So no need to create ourselves. We just to understand that we have created a class for us. So then the same thing, stack dot push object, let's 23. Then stack dot push, same thing, same way the way we have implemented array stack, the same way you can implement stack push. So all this thing, these are like abstract, everything is abstract class. Everything is already done. Now we need to use the stack class, stack dot pop. Same way we need to just implement it. Okay, so if you run this, it will work. See, everything is working. So this is how it is. Okay, so this is all about stack. And then next we'll go for queue. Thank you so much.